Welcome back to video lesson grade 11s. I want to continue the lesson we had in class on using the table of reduction potentials to write a net redox reaction. So our example is as follows. We've got copper reacting with a silver nitrate solution. And what happens is the copper displaces the silver from its solution. So we need to use the table of reduction potentials to write a balanced equation. The first thing we do is we find out which reagent is the reducing agent and which one is the oxidizing agent. Now, it will help if you write down the oxidation numbers. For the elements. So copper has an oxidation number of 0 here. Silver has an oxidation number of +1. I know that because the nitrate ion NO3 negative has a 1 negative charge. The oxygen's oxidation number is -2. If we've got a -2 for oxygen and there are 3 oxygens, it adds up to a -6 charge, of which 1 remains on the ion. So there are 5 negative charges that needs to be cancelled out. So the nitrogen's oxidation number is +5. The copper here has an oxidation number of +2. The nitrate remained unchanged, so it's +5 for nitrogen and -2 for oxygen, and silver's oxidation number is 0. You will find the copper on the table of reduction potentials. The copper on the table of reduction potentials changing to copper 2+ is the reducing agent. And the silver ion on the table of reduction potentials is an oxidizing agent. You will also find that nitrate is an oxidizing agent on the table, but because it didn't change, it remained unchanged. It's called a spectator ion. So, our reducing agent is the one that is oxidized. So if you find the reaction on the table, you have to write down the reverse reaction, starting from the left-hand side. So copper is oxidized to copper 2+, and it gives 2 electrons. So loss of electrons is oxidation. The oxidizing agent is reduced, so the reduction half reaction starts off with the silver ion, and we use the forward reaction on the table. Silver ion plus an electron goes to the silver atoms. Now, the number of electrons that are released by the copper must be the same as the number of electrons that are gained by the silver. So we need 2 silver ions will take the 2 electrons given off by the copper, and for every 1 atom of copper going into solution, there will be 2 atoms of silver deposited. So from here, with the number of electrons being balanced, we can write the net redox reaction, where copper and 2 silver ions will give you copper 2 plus ions and 2 silver atoms. Just to add on to this is a spontaneous redox reaction. Because the copper is a stronger reducing agent than silver, and will therefore reduce silver ions to silver spontaneously. This brings us to the end of this lesson. In the next lesson, I will show you how to write a balanced equation without the use of table, the reduction table. Thank you for watching. I'm sorry, I made a mistake. I've got another example to work through. Now, in using the table of reduction potentials, we can find H2S on the table. It is on the reducing agent side of the table, so H2S is our reducing agent. Then we look at FeCl3, and there are 2 separate things in there. The Fe, because it's an ionic bond, so you'll have Fe3 plus in this compound, and you'll have Cl negative in your compound. Now the Fe3 plus, you will find more than one Fe3 plus ions on the table, but they are all the oxidizing agent. And I'm going to talk about the Fe3 plus in a moment. If you look at the Cl negative, the chloride ion is another reducing agent, but it is a weaker reducing agent than H2S because it's lower down on the table of reduction potentials on the side of the reducing agents. So Cl negative will be a spectator ion in this reaction. Now we need to look at another matter, and that is that you have an Fe3 plus ion at the number negative 0.06 as well as at the 0 plus 0.77. Now those are voltages, but we'll discuss that in grade 12. Now, the one at the 0.06, that one will lead to a non-spontaneous reaction with the hydrogen sulfide, because for that the Fe ion is a stronger reducing agent than the H2S. So that reaction will not take place. So we need to look at the reaction where the electrode potential is 0.77 in our answer to this question. So our oxidation half reaction would be the H2S changing to sulfur, 2 hydrogen ions, and giving off 2 electrons. The oxidizing agent, which will form the reduction half reaction, would take Fe3+, absorbing 1 electron, gaining 1 electron to make Fe2+. So this is the reaction that will lead to a spontaneous redox reaction. To balance the equation, we need 2 iron 3+, that will take in 2 electrons to give 2 iron 3+. In the final instance, the net redox reaction would be H2S plus 2 Fe3+, going to sulfur plus 2 hydrogen ions and 2 Fe2+ ions. So this is the net redox reaction, the reaction in ionic form. Thank you for watching the video. I hope it helps to understand the work.